This lesson is on adding and subtracting radical expressions. Doing this is actually the same thing as gathering like terms once the terms are simplified. So we need to simplify the radicals and gather our like terms. So remember, like terms have the exact same endings. So in this case, they'll have the same radical factors when simplified. For example, root 2x, which is like 1 times root 2x, negative 15 times root 2x, and 5 times root 2x are all like terms. They have the same endings. So you could combine those like terms now that they have the same endings and calculate and say, instead of all of this, I can say I have 1 of these minus 15 of these plus 5 of these gives me negative 9 of these. Notice that you can collect them, and it's almost easier to collect them once they've been simplified. In fact, it is easier because then you know that the endings are the same. If the endings are not the same, for example here, root 2 versus cube root of 2, those are not like terms and cannot be combined, so you just leave them. Let's take a look at an example. Simplify root 20 plus root 45. So, right now, these are not like terms, but if we simplify first, then we can see if we can have the same endings, and the only way to do that is to completely simplify each one first. So, as in the previous lesson, let's consider what 20 is made up of. 20 is factored into 2 times 10 and 2 times 5. So we can rewrite root 20 as 2 times 2 times 5. We can rewrite 45 as 5 times 9, and 9 is 3 times 3. So 45 can be written as 5 times 3 times 3. Breaking it down makes it easier for us to locate the perfect squares. Notice here we've got a perfect square of 4, which gives us a 2, and we've got a 5 left inside. Here we've got a 5 left inside, and we've got a perfect square of 9, which gives us a 3 when rooted. So that gives us 2 root 5 and 3 root 5. Hey, voila! Same endings. So we can say we have 2 of these plus 3 of these gives us 5 of these, and the these part was the root 5. So adding and subtracting radicals is all about simplifying the radicals and collecting like terms. Let's continue on to a few more complicated examples. Here we've got some more complicated examples where we have to simplify both the numbers and the letters. So let's begin. 28 is made up of 2 times 14, which is 2 times 7. So the root of 28x squared y can be written as 2 times 2 times 7 times x squared times y minus 2 root 63 is probably divisible by 3. Let's check that out. 63 divided by 3 gives us 21, and 21 is 3 times 7. So 63 can be written as 3 times 3 times 7 times y, and instead of writing y cubed, we want to write it in even components so that we can square root. So we'd write it as y squared times y. So let's group it up. We can see that 2 2's make a 4, and root 4 becomes 2. 7 has to stay. Root of x squared gives us x. Y has to stay. The 3's come out, the 7 stays, y comes out, and a y stays. Here we go. We got 2x root 7y minus, now we can multiply the 2 times the 3 and the y, gives us 6y root 7y. Okay, now this is a great example of a place where you would likely try to combine them, but You can't, because the endings are not the same. Notice that these endings are not the same because one has an x and one has a y. Even though the root is the same, the variable component is not the same. In this case, we just leave it. That's all you can do with it. Leave it as it is. Let's look at the next one. Remember to try this out first and then look at how I've done it. Maybe I've done it a little different than you, but they should be leading to the same result. 48 is 2 times 24, 24 is 3 times 8, 8 is 2 times 4, 4 is 2 times 2. Now when I write these, I'm probably going to write all the 2's first and then the 3. So we've got x root 2 times 2 times 2 times 2 times 3 times x times y squared minus 27 can be written as 3 times 9, 3 times 3, 3 times 3 times 3, x squared times x gives us x cubed, and 75 can be written as 3 times 25, 5 times 5. So that's 3 times 5 times 5 times x squared times x times y squared. Let's pull out the perfect squares. We've got a 2, a 2. Remember, there's a square root, so we're looking for pairs. 3 is left alone, x is left alone, and y comes out. 3. 3 is left. From x squared we can have an x, and x is left also. 3 is left alone, 5's come out. X squared becomes an x. X is left, and y squared becomes a y. Now we've got x times 2 times 2 times y on the outside of the root because those have been simplified, leaving us with 4xy. And inside the root we have 3x minus, here we've got 3 times y times x. We usually write the number first and then alphabetical order in order to make sure that we see common terms in the future. So 3x is left inside. And in the last one we've got 5xy coming out, and we've got 3x left inside as well. Now you can see that the endings, the variable component, the variable slash root component of each term is the same. So you can combine them. You have 4xy root 3x's minus 3xy root 3x's plus 5xy root 3x's. 4 minus 3 is 1 plus 5 is 6. So you have 6xy root 3x's. Now, let's consider what would happen with cube roots. It's exactly the same thing, in fact, because you're just simplifying and looking for like terms. Let's take a look. We can rewrite 8 as 2 times 2 times 2. You can justify that for yourself. X to the 5 can be written as x cubed times x squared. Notice the cube will come out, but the square will not make a triple. Because we've got cube roots, we're looking for triples of factors which cause cubes to happen. So now 27 is 3 times 3 times 3. X to the 8 can be written as x to the 6 times x to the 2. 6 is a multiple of 3 and 2 is not. You could also just write them out and circle the triples out as well. Let's identify our perfect cubes. So 3 2's come out as 1 2 because that's 8. Cube root of 8 is 2. 3 x's make 1x. X squared is left. Triple of 3's. There's 2 triples of x's within the x to the 6. So you could say x squared cubed gives us x to the 6, and x squared is left. So that leaves us with 2x cube root of x squared minus 3x squared cube root of x squared. Again, you may notice that the endings are almost the same, except for this square. Since they're different, you cannot combine them and you have to leave them. Let's look at the last example here. Find the total length of a quadrilateral with side lengths given below. So we've got 4 sides. We want to basically just add all of these numbers together. So let's first simplify as much as possible. Here we've got 10 and root 150. Notice that 150 can be written as 10 times 15, 2 times 5, 3 times 5. So I'm going to write that as 2 times 3 times 5 times 5. And our root doesn't need to be that long. And 7 root 54 is 2 times 27. 27 is 3 times 9. 9 is 3 times 3, which is 2 times 3 times 3 times 3. And 9 root 96 is 2 times 48, 2 times 24, 3 times 8, 2 times 4, 2 times 2. Yikes, that's a big one. So 2 times 2 times 2 times 2 times 2, make sure you have enough, and then times 3. And the last one is root 24, which is 2 times 12, which is 2 times 6, which is 2 times 3. Let's check that. 4 times 6 is 24. Yes, it is. So you can sometimes do them in your head if possible, or write them out on the side. Now these are square roots, so we want to look for pairs. The 2 and the 3 do not have pairs, but the pair of 5s makes a root of 25, which is 5. 2 double 3s, 3 left, 2, 2, and 2 and 3 left inside, 2, and 2 and 3 left inside. So you can see that this method can be efficient in not having to rewrite everything over again. So that gives us 10 times 5, which is 50 root 6, plus 7 times 3, which is 21 root 6, plus 9 times 2 times 2, so 18 times 2, which is 36 root 6, plus 13 times 2, which is 26 root 6. You see that all the endings are the same. So we can just go ahead and add that. So 50 plus 21 plus 36 plus 26 is 103 root 6s. In this case, it's in feet. I'd like to make one note here in that if one of these were different, for example, if you simplified, different question here, if you simplified and you got, say, 2 root 3 plus 5 root 3 minus 2 root 2. So say one of them was different, but 2 of them were the same. It's just like terms. You collect the ones that are like, you leave the ones that aren't. So in this case, that would be 7 root 3 minus 2 root 2, and that's fine. You just leave it like that. That's all you can do in that case.